Good morning, everyone, and this is lecture number 3, and we are still dealing with distance and displacement. In the previous class, we saw an example of finding out the distance and displacement, and I told you two different ways of doing it. One was the way where we had found out the magnitude and direction of displacement. Do we remember this? We had done a question where a particle moves north, then it moves east. Then we had found out the magnitude of displacement, and then we have written the direction of displacement, and that is how we have solved that question. Do we remember this? That is one way of doing it. The second way, as we had seen it, was straight away writing the displacement as a vector quantity. So we had written it as a vector quantity, and once you write it as a vector quantity, direction and the magnitude, it follows. We understand this? Okay, let us move ahead. Let us move ahead and let me give you another question based on the same concept of distance and displacement. To understand the concept of distance and displacement, let us do this. I hope everyone is there. Oops, what is this? Not good. Okay, let us say, remember, the name of the chapter that we are dealing with is motion in a straight line. But as you can see, the question that we are doing, they might not be only straight line question. That means we are dealing with motion in general. As you can see, this is a circular path. Do all of you see this? Yes or no? The circular path has the origin O, and the radius of this circular path is R. A body or a man starts walking from the point A and he reaches point B. So he's traveling from A to B. Is the question clear to everyone? He travels from A to B. The question is very simple. What is the distance traveled by the man or the particle, and what is the displacement of the particle? The first question that I would ask, is this motion in one dimension? Motion in, is it motion in one dimension? Is it motion in two dimension, or is it motion in three dimension? 1, 2, or 3? The question that we are doing, is it an example of 1D motion, 2D motion, or 3D motion? Tell me. One D motion. This question is an example of 1D motion. Do you have a mic that works, beta? Do you have a mic that works? No class has mic?
2D motion.
Yes, beta. Tell me. I'm trying to listen to you if you are saying something.
2D motion, sir.
Yes, beta?
2D.
Yes, it's an example of motion in 2D. The motion is taking place in a plane. So this is an example of motion in 2 dimensions. But remember, the definitions that we have learned, the definition that we have understood, they are valid whether the motion takes place in 1 dimension, 2 dimension, or 3 dimension. Do we understand this? Do we understand this? Yes or no? Okay, now the first question is, since we have understood that this is an example of motion in 2D, that is the first thing that we have to understand. That means, though the name of the chapter is 1D, we are doing all types of Ds. Now the question is, the particle or the man has moved from point A to point B. The first question is, what is the distance traveled by the particle or the man? What is the distance traveled by the man? Can anyone tell me the answer for this? What is the distance traveled by the man? I hope everyone is noting down the question and trying to solve it. What is the distance traveled by the man?
Two pi r, sir.
He has gone from A to B, beta. Please think again. It's gone from A to B.
Pi r by 2.
Pi r by 2. Can you tell me how did you get this answer, pi r by 2? That is correct. Can you tell me how did you get this answer, pi r by 2?
Sir, circumference of a circle is 2 pi r.
Circumference of the circle is 2 pi r. No. First of all, tell me that you have to find out the length of this path. Yes or no? You have to find out how much is the length of this path. The length of this path is the distance. Yes or no?
Sir.
Now, once you understand that length of the path is the distance, you have to find out how much is the length of the path. How do you find out the length of this path? The total circumference is 2 pi r. It is 1/4. So answer is pi r by 2. Yes or no? Do we all understand this? Well done. Now the second question is, what is the displacement of the particle? And let me have answers for this. What is the displacement of the particle?
Root 2 r.
What is root 2 r, beta?
Displacement.
What type of quantity is displacement, beta?
Shortest.
What type of quantity is displacement, beta?
Radius, sir.
Radius? Sorry, I did not get you, beta. What type of quantity is displacement?
Vector quantity, sir.
Vector quantity, yes. When you are telling me root 2r, what are you telling me? Root 2r does not tell me anything about the displacement vector. I am looking at the sky because I don't understand it. Try again. What is the displacement here? Try again. Try. What is the displacement here? Tell me. No one? How many of you have read the notes before coming to the class? Please raise hands. Only one girl, one boy. The rest of, I can see one more boy from the left-hand side or the right-hand side of the screen. Remember, beta, if you are thinking that just sitting in the class and doing nothing, you'll sit in the class. This is not a temple, and I am not a Baba, though I may look like a Baba, that I will give you pravachan. You will listen to that pravachan and then you will become bhakt and oh, kya, Ashirwad barsega and you will all become rich. And one day, all of a sudden, you will find yourself in an IIT of your choice. That is not going to happen. I am no Baba. And I am no Dumbledore, and this is not Hogwarts, and you are not Harry Potter and Hermione that I can teach you wizardry. Move this, and you are into an IIT. It doesn't happen. To get anywhere close onto the road of an IIT, you will have to do your karma. And if you don't study before coming to the class, And remember, physics is going to get very tough. For
Root
you
is
right
magnitude,
now,
sir.
it may be very easy, but if you don't do it the way that I tell you to do it, you will find yourself in trouble, and very soon so. So please follow my instructions. If I tell you to steady and calm, you do it. Else you will land up in trouble. Do we understand this? Okay, well done. Try again. Displacement is a vector quantity. If you tell me root 2r, what are you telling me?
Magnitude.
Well done. That is how you say. So instead of doing all this, you could have straight away said, sir, the displacement is simply this AB vector. Yes or no? This is how you should have told me the answer. Sir, the displacement is simply AB vector. I joined the initial position to the final position, and that is my displacement vector. Do we understand this? Displacement is my AB vector. Now, sir, I will tell you the magnitude of that vector. The magnitude of this vector is the length of this line. How much is the length of this line? This is R, and this is R, and this is Pythagorean theorem. Yes or no? So the hypotenuse becomes R square plus R square ka root. So the magnitude of this displacement becomes root 2R. Do we understand this? Well done, well done. Okay, so the magnitude of this displacement, is root 2R. But sir, please sir, understand sir that this is a vector. So I must also tell you the direction. The direction can be said in this way. Sir, I will tell you this angle, sir. This angle theta, sir, that it makes with the x-axis, sir. How much is this angle theta? Because you have to tell me the direction as well. How much is this angle theta? How do you get the value of this angle theta? You can find out the value of tan theta. Yes or no, my dear friends? What is the value of tan theta here? Can anyone tell me? This is simple maths.
45 degrees, sir.
45 degrees. How did you get? Perpendicular divided by base. Yes or no?
Sir.
Now the answer is correct, that tan theta is 45. Oh, sorry, tan theta is 1 and theta is 45. Now, sir, I have told you both the things, sir. I have told you the magnitude, sir. I have told you the direction, sir. And that is the answer, sir. Do you understand this? Because these simple things, beta, are going to get very complicated when we move further ahead in life. So it is good that you can take the onus here, take some time here to understand them correctly so that your life becomes easier going ahead. Shall we move on? Okay, this is not the only way of doing it. I told you we could have said this in terms of I and J. Yes or no? Now, in terms of I and J, let me call this as origin. Let me call this as my y-axis, obviously positive y. And let me call this as positive x-axis. This is my positive y and this is my positive x. Now I would be very happy. This is my origin. I would be very happy if anyone can tell me the same displacement in terms of I and J.
I cap plus RJ cap.
Remember, bacha, this is my y-axis. This is my y-axis and this is my x-axis. I would be very happy if you can tell me this displacement in terms of I and J. Yes, beta. What is your answer? Tell me. AB vector.
B is equals to RI cap plus RJ cap.
Remember, beta, displacement vector is final position vector minus initial position vector. So what is the final position vector here? Final position vector is this vector. Yes or no? And final position vector is R times J. Yes or no? And initial position vector is this vector. Yes or no? This vector, the blue vector, is my initial position vector. And this vector, green vector, is my final position vector. Final position vector, initial position vector. Final vector minus initial vector. Final vector is Rj. What is the initial vector? Ri. That is the answer in terms of I and J. Do we understand this? Do we understand this? It's not important that you may write it like this, because most probably the answer will not be in the form of vectors. Most likely the answer will be in the form of magnitude and direction. But in JEE Advanced, you can expect the answer to be in the form of vector. That only might come in JEE Advanced. It may not come normally. Do we understand this? Have you got the answer for this? Okay, I'll give you 1 minute and then I will solve one more question. This is from your sheet. Did you get the DPP that I sent you? Did you get that practice problems? This is a yes, this is a no. Okay, not a problem. Still, this is problem number 1 from your sheet, and I hope that you get the sheet today. And a problem from your sheet, Control V. Here it comes on your screens now. A body moves 6 meters north, 8 meters east, and 10 meters vertically upwards. What is the displacement of the particle? Here, they have not told you about the direction, so they are basically asking you the magnitude. Do we understand this? They're asking you the magnitude of displacement. Okay, I see thumbs up from everyone. Let us wait for the correct answer. This is question number 1 from your DPP sheet, practice sheet. Question number 1. Yes, my dear friends. Do we have an answer? You don't have to write the exact question, bacha. You will get this sheet. Just write sheet question number 1. That's it. We cannot waste time in writing a question unless and until this question is not there. This is a very simple question. Just write the question number. The sheet is already on its way. I have sent it 5 days ago. I will make sure that you get it now. Just write. Just tell me the answer. Yes. Tell me there is no right and no wrong answers. I just want to understand how you have done it, and then I'll give you my views. Yes, bacha. Yes, anyone with an answer? First of all, tell me, is what type of motion is this? Is this 1D, 2D, or 3D?
3D.
3D, yes or no? He's moving right, he's moving left, he's also moving up and down. So this is a case of 3D motion. Yes, now tell me the answer. What is the displacement? So if I talk about the displacement, let me write it as delta R vector. He moves 6 meters north, so I can call it 6J. Remember, my north. Okay, wonderful. My axes are here. My x-axis, my y-axis, and my z-axis. Do we get this? X, y, and z-axis. Positive x, positive y, positive z. So, first of all, he walks 6 meters like this. So I write 6j, yes or no? Then I write 8 meters like this. And then it moves upwards. Now I cannot draw this on this. You understand this now? My problem? So now it moves upward. So I will write it like this along the z-axis. Along the z-axis. I hope you are getting my point, bacha. This is not like this. It is along z-axis. Do you understand this? I cannot draw this because my board is two-dimensional. So how do I get this? I write the displacement 6 along j. Then the next part is 8 along I. And the last part is 10 meter upward. So upward is z-axis. Yes or no? So it is plus 10k. Do we understand this, everyone? How do I get the magnitude of this thing? This is very simple, my dear friends. The magnitude of displacement, I can write it as delta R. The magnitude of displacement will be under root of, tell me what? Distance formula here.
Plus 10 square.
Well done. 6 square plus 8 square plus 10 square. That is the answer, my dear friends. So which is the option correct? A, B, C, D?
A.
A is the correct option. That is absolutely correct. All of you who have got the correct answer, please raise your hands. No one from the Tanaka Center got the answer? Not bad, not good, not good, not good.
Got the answer, sir.
Okay. Again, please remember, you don't have to write the question. You just have to write the question number. Move ahead because this is question from your practice sheets only. Control V, comes the next question. And here is the question. If the displacement of a particle is 0, then what can be said about the distance covered? It must be 0. It cannot be 0. It is negative. It may or
Option
may
B.
not be 0. And the answer is?
Option B.
Option B, it cannot be 0. Do we understand this? Yes or no? No, yes. Distance is a scalar. It is a number. It can never be negative. It can never be 0 unless and until the particle is at rest. If the particle is at rest, it becomes 0. Yes or no? No, yes. These are the type of question, my dear friends, that we expect in an examination hall. I hope you have gotten the pattern of the question. Here comes the next one. It is again, this is question number 5 from your sheet only. The location of a particle has changed. What can we say about the displacement and the distance covered by the particle? The options are right in front of you. A, B, C, D. Which is the correct answer? Don't have to write down the question, just write the question number. As I have told you, this is question number 4 from your DPP sheet. This is question number 5 from your DPP sheet. Yes, bacha. Why is everyone writing something? I told you not to write, just tell me the answer. Concentrate on the question, not the writing part. I told you the sheet is already there. Yes. A, B, C, D. A, B, C, D. Which is the correct answer? Which one? How many think that A is the correct answer? And A is the correct answer. Both cannot be 0. The particle has moved. Distance cannot be 0. The position has changed. It is not coming back to its original position. Therefore, displacement is also known 0. So the answer is both cannot be 0. Do we understand this? If it would have come back to its original position, then displacement would have been 0, but distance still would have been not 0. Do we understand this? Okay, so these were the questions from your sheet, and I will leave the rest of the question. 2 or 3 more questions are there for you to solve from the sheet. And also I will give you a question for homework. I think this is from your module. You can solve it here also if you wish to. So do it quickly so that I can log this topic and then I can move ahead in life. So this is the question that we are looking at. Ram takes path 1, straight line, to go from P to Q. Sham takes path 2, which is semicircle, from P to Q. Find the distance traveled by Ram and Sham. Find the displacement of Ram and Sham. Remember, when the question comes, they might not specify magnitude of displacement. But if they simply say displacement, they mean magnitude of displacement. Because of questions like this that you find in books, the concept of vector with displacement goes away. But remember, whenever they're asking you for the displacement, probably they're asking you the magnitude of displacement. Do we understand this? Here is the question. Don't have to write the entire question. You just have to draw the diagram. Ram goes straight, Sham goes along the semicircle. And I wait for your answers. Can I expect an answer now? Was it too early? Is it such a difficult question? It is taking
Ram
so much.
100 meters. Ram 100 meters.
Okay. What Ram 100 meters? First of all, tell me the distance. Yeah. So say something. Distance traveled by Ram. Yes. What is the answer?
100 meters.
Distance traveled by Ram is the length of the path. He has gone straight. That is 100 meters. I hope everyone got this. Yes or no?
Sham 157.
Distance traveled by Sham. Now to get the distance traveled by Sham, what you got to do is you have to find the length of this path, which is a semicircle. Yes or no? Circumference of half of the circle, semicircle, and that will be equal to pi multiplied by r. Yes or no, bacha?
Yes, sir.
Pi is pi, r is 50, so the answer is 50 pi. Do we get this, everyone? Well done. Now let us move on to the next part, displacement. Displacement of Ram. Yes, bacha, what is the displacement of Ram? To find the
100 meters, sir.
To find the displacement of Ram, we must join the initial position to the final position. That is PQ vector. So I can just write it as PQ vector. Do we understand this, bacha? And I can now write the magnitude of this PQ vector is 100 meters. and you can write the direction along plus x-axis. Yes or no? Yes or no? They have not asked the direction, doesn't matter. I have written everything. I will not write half of the thing. What about Sham? Is it displacement same or different? What about Sham? What about Sham? Is the displacement same or is the displacement different?
Different, sir.
So what is the displacement of Sham?
100 meters, sir.
Same or
Plus
different?
x-axis.
Same or different?
Same as Ram, sir.
Why it is same as Ram? Because the initial and the final positions are same. Ram also starts from the same initial position and the same final position. Sham also starts from the same initial position and same final position. Their distances are different, but their displacements are same. Do we understand this? Have we noted this down? Remember, we have noted it down. Distance depends on the path. Displacement is independent of path. It only depends on initial and final position. And this is a very good example where we understand that though Ram and Sham are traveling different distances, the displacements are same. Anyone has any doubt, please ask. Else you will note it down and we'll move on to the next category, next set of definitions. Shall we move ahead? Everyone has noted it down? Okay. What would be the next heading? Next definition, next heading, yes.
Speed.
Speed. Now let us first understand speed. What do you mean by speed? Let us write it point-wise. Speed. What do you understand by speed? Yes, fatafat. Speed.
Rate of distance covered by body.
Rate. And I hope everyone is writing it with me. Rate of distance covered by body with time. Do we understand time? With time, how much distance the body is covering? That is known as speed. If the body is covering large distances with time, we will say it is moving very fast. The speed is very high. If it's covering very small distances in time, we will say the speed is less. What type of quantity is, okay, how do we represent speed? Now, in most of the cases, speed is represented by V, yes or no? But we can use V for velocity as well. So I will use S or V for speed. Remember, S is not used for displacement. We have used delta R for displacement. Do we remember this? Okay, so that's change in symbols. I hope you don't get confused. So V, when I say V, it reminds me of velocity. So I use S for speed. Is it okay to use S for speed? Yes or no? S standing for speed. Okay. What type of quantity is speed?
Scalar.
Scalar. So it only has magnitude. Speed is a scalar quantity. What is the SI unit?
Meter.
SI unit?
Meter per second.
Meter per second. And the dimension? LT minus 1. Will you remember this? Okay. So let us now move on to the types of speed. We can call this section as the type of speed. Doesn't matter. What is the first type of speed that you have heard about?
Uniform speed.
What is uniform speed? Uniform speed.
If a particle covers equal distance in equal time of intervals.
Equal distances in equal intervals of time. Do we all understand this? And I hope everyone is noting this down. Yes or no? No, yes. So body covers equal distances in equal intervals of time, no matter how small or how big it is. We call it to be moving with uniform speed. Do we understand this, bacha? This is a yes, this is a no. So here it is what illustrated in the diagram as well. As you can see, this is a motorcyclist. And look, in every 1 second, he is moving a distance of 5 meters. 5 meters, 5 meters, 5 meters, 5 meters, 5 meters. Time 1 second, 1 second, 1 second, 1 second, 1 second. And his speed is uniform. Sometimes we can call this uniform speed as constant speed also. So this uniform speed can also be called as constant speed. Do we understand this? Yes or no? No, yes. So someone tells you the body is moving with a uniform speed. It means that the speed is constant with time. So you can also understand this in this way. A body moves equal distances in equal intervals of time. You can say it this way, or you can also say it is moving with constant speed. Do we understand this? Yes or no? No or yes? This is a yes, this is a no. Remember, all these small things are going to make a lot of difference in the eventual answer. As everyone noted this down, you don't have to write too much. Just write equal distances in equal intervals of time. It is moving with constant speed. This is just to show you how it moves. Shall we move ahead? If the first type of speed was uniform speed, what is the second type of speed?
Non-uniform speed.
The second type of speed would definitely be non-uniform speed. So write the heading non-uniform speed, or instead of using the word non-uniform, you can also use the word variable speed. A particle or a body moving with variable speed. Now, once you have understood non-uniform speed, you can probably tell me what do you mean by variable speed. Yes?
If a particle covers equal distance in unequal time of interval.
See, we don't make time of intervals as unequal. So now let us try to reframe the definition again.
Equal distance in equal time.
Unequal distances, that would be better. Unequal distances in equal intervals of time. Do we understand this? That is a better way of saying it. Do we understand this, bacha? Non-uniform or variable speed. Speed is going to constantly change with time. So you can also understand this word. If the speed is changing with time, so variable or changing speed or non-uniform speed, they all mean the same thing. Anyone is there with me on this? Yes or no? No, yes? and then I will show you a small picture. Of non-uniform speed. As you can see, again, the same cyclist. Intervals of time is same, 1 second each. As you can see now, first 1 second, 5, then 8, then 10, then 4, then 6, then 7. And therefore, speed is variable 5, 8 meter per second, 10, 4, 6, 7 meter per second. This is an example of a particle moving with non-uniform or variable or not constant or whatever you call it. Everyone has noted this down. You don't have to write the entire history. Just write equal, unequal distances in equal intervals of time and just understand it. What is the third type, if there is any third type of speed?
Average speed.
Well done. That is the next one. Average speed. Now, to write average speed, we will use this dabba. Dabba means average. You understand this dabba? Box. So if you use V for speed, dabba V means average speed. I am going to use S for speed. So dabba S means average speed. Do we understand this? S in a dabba, X in a box is average speed. Yes. Since you know this, tell me what is average speed.
Total distance covered by total time taken.
Well done. It is as simple as this. Total distance divided by total time. That is, my dear friends, my average speed. So I will write it like this. Dung, 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 dung. S in dabba is L divided by T. What does L stand for here, my dear friends? L is our old friend.
Distance.
L is our old friend, distance, yes. T is our new friend, time. Total distance divided by total time. And remember one important aspect about this average speed, my dear friends. This average speed is always calculated on an interval of time. So let me just write it this way probably. An important aspect of this average speed is it is always calculated for an interval of time from 1 second to 2 seconds, from 5 seconds to 10 seconds, from home to office, from home to school, from school to home, and so on. Do we understand this? Average speed is only calculated. Well done. Now we are picking up some speed. Average speed. If there is a fourth type of speed, what would that be?
Instantaneous speed.
Which one, beta? Instantaneous. Is that the word that you were telling me? Instantaneous speed. Instantaneous speed. Now, to use this instantaneous speed, I will use the symbol V or S. Now, as soon as I use the symbol for instantaneous speed as V or S, that reminds me that it was the same symbol I used for speed as such. See, this green thing, V and S. And this the blue thing, VNS. Now remember, whenever in general we are talking about speed, for example, you are driving in a car and I call you up and I say, beta, what is your speed? So you are going to look at the How are you going to tell me your speed? Just tell me. Call you up. You are in a car, you are traveling, and I ask you, beta, what is your speed? So what are you going to tell me? And how are you going to tell me? Yes, it's a simple, practical question. You are in a car, and I ask you, what is your speed? What are you going to tell me, and how are you going to tell me? Yes? No one can tell me. Shameful. Okay. Maybe you have not understood the question from a car. You are on your bike. And then I ask you the same question. Obviously, you will say, sir, don't call me while I'm riding because that is against the traffic rule. Okay, I understand that. So probably someone else is riding and you are sitting at the back. Now you can talk with me. And I ask you, what is the speed? What do you tell me? And how do you
The
tell me?
speed is traveling in speedometer. With speedometer, we'll say, sir.
Yes, you will look at the speedometer and tell me, sir, right, sir, my speed is 40 kilometers per hour. But after 2 seconds, it might change. Yes or no? Because you might encounter a traffic light, you might encounter traffic. So now, after 2 seconds, it may become 30 kilometers per hour. After 5 more seconds, when the road is empty, it may become 60 kilometers per hour. Yes or no? That is your instantaneous speed. So invariably, whenever we use the word speed, we mean the word instantaneous speed. Do we understand this?
Yes, sir.
And actually, the definition that we have written is actually the definition of instantaneous speed. Now, what do you mean by instantaneous speed? If I want to write it, instantaneous means right now. Instantaneous means?
Speed at any instant, sir.
Yes. So this is the speed of the body at any instant. Well done. So this is the speed at any instant. And it is given by the speedometer. It is given by your speedometer. Do we understand this? Yes or no? No or yes? Instantaneous speed is your speed at any instant. It is given by the speedometer. And if I write the formula, instantaneous speed S, I write is delta L by delta T. When I say delta L by delta T, I mean distance divided by time, and I take the limit of time to 0. Now it may sound very difficult, but this is all maths. You don't have to remember this. You can just remember it like this. dl by dt. Do you understand the meaning of dl and dt? dl means
Yeah.
very small distance divided by very small time. Do we understand this? Or you can also call it rate of change of distance with time. That is your instantaneous speed. Do we understand this? One more thing that I have to tell you, and if I tell you right now, it may be a little bit early. So you leave 1 or 2 lines with a star mark because we are going to deal with that star mark in the next class. Do you understand this? So you leave 2 lines, 1 or 2 lines.
Yes, sir.
Okay, so that I can fill up these 2 lines in the next class. Now, before ending up this class, again, I shall give you a question. And here comes the question. Remember, every question that comes may come in your exam also. And remember, every question that we solve is based on what we have learned. This is again a question from your DPP, from your sheet. And if I tell you the question number is 10, a car moves for half of its time at 80 km per hour and the rest half of time at 40 km per hour. Total distance is 60 kilometers. What is the average speed? Can you do it? Take this question as a homework. Okay? Take this question as a homework. Note it down. Try it if you can. Else, don't worry. We are going to solve this question and many such questions in the coming class. Do not miss this class. Do not miss the class for anything. Class is the most important aspect of your preparation. So I'll see you in the next class. Be on time. We'll be solving a lot of questions in the next class. Don't worry about it. And I'll see you in the next class. If anyone has any doubt, have you noted down this question? We'll do some questions of this nature because a question of this nature has come many times. I might also share you one more sheet which consists of questions from the previous years. I have got that sheet, so I might share you that sheet as well. And we will be solving questions from both of the sheets as we move ahead. So if you can just solve the sheet that I have sent you and that previous year question wala sheet that I sent you, that should be good enough for you to clear any exam. If you want more practice, well, practice makes a man perfect. So the more the number of questions you do, the better you are going to become. Before the next class, please go through what we have done in this class. Take care.
Thank you, sir.
Have a nice day. God bless you all, bacha. And take a good care of your health. It's very scary that
Thank
so
you,
many of
sir.
students have got unwell. Take care.